So this problem is incorrectly written. First off, it says the non-zero complex number system is closed, meaning that whenever you do these operations, addition, subtraction, multiplication, division, whenever you do these operations in the non-zero complex number system, you get another non-zero complex number. That's what closed means. And this is not true for addition and subtraction, because I can do 2 plus 3i plus -2 minus 3i. These are both complex numbers. If I add them, I get 0. And if I take 2 plus 3i minus itself, 2 plus 3i, these are again two complex numbers. They happen to be the same number, but they're just still complex. And that gives you 0. So technically 1 is incorrect. However, the solution to this problem says it is addition and subtraction is closed. If it was just a regular complex number system, then addition and subtraction would be closed. But because the non-zero portion is stated here, that's what makes this addition and subtraction not work. Now, multiplication, on the other hand, is a separate thing. So when you multiply two complex numbers, really what you're doing is you're doing this. So A, B, C, and D, these are just real numbers, and you're multiplying them together. And if you do this whole operation out, you're going to get A times, let's see, A times C, and then BI times DI is going to be B times DI squared. That's going to be negative BD. That's a real number. And that's the first part. And then we're going to add that on to the complex portion, which is going to be A times DI, and then B times C, so plus B times C, and that's going to be multiplied by I. So this is the real portion, and this is the complex portion. And to make this 0, you'd have to have both of these parts equal to 0. And it's kind of hard to do without testing some numbers. But if you test some numbers, you're going to see the only way you get 0 is if maybe all the numbers are 0. Like A, B, C, and D are all 0. But we're in the non-zero complex number system, so they all can't be 0. Also, if you test it all, like using different numbers, you're going to see that A, B, C, or D have to be a complex number, but A, B, C, and D are all going to be real numbers. That's how we wrote this out. The I is what brings in the complex portion. So A, B, C, and D should not have I in it at all. And when you test some numbers out, you're going to see that it's going to either have to be all of them 0, or some of them are going to have to be complex numbers for it to actually give you 0 as a result. So because this cannot happen, that means multiplication is closed under complex number, the non-zero complex number system. Now, division is slightly different, but it actually ends up being true by the same reasoning. To do this, really what we do is we multiply by the conjugate of the denominator. And you're going to see we end up getting A plus BI on top, C minus DI, A plus BI times C plus DI, C minus DI on top. And on bottom, we're going to get C squared plus D squared. C squared plus D squared is just a real number. It's not anything fancy. It's not even a complex number. Purely complex number. It's going to be a real number. Real numbers are complex numbers. But what we end up having here is some real number. Let's just say 1 over x, for instance. And then we have A plus BI, C minus DI. This is really just multiplication of two complex numbers. And we already showed that multiplication of two complex numbers is never equal to 0. So therefore, this will never equal 0 as well. So actually, 2 and 3 are the only ones that are true, D. But the book says A is correct, which is not true.